Hi, I'm Karthik Avinash from Future AGI. Today I'll introduce Protect, our open source guardrailing system that detects threats like prompt injection, toxicity, bias, and data leaks in less than 100 milliseconds. Protect is built on Google's Gamma 3n with specialized LoRa adapters, and you can find all 4 such adapters which are exclusively fine-tuned on our curated text dataset on our Hugging Face page. In this cookbook, I'll walk you through inferencing or fine-tuned prompt injection adapter model using VLLM for production purpose. Now in real-world applications like a live chatbot or a content moderation system, every millisecond matters. You need to catch threats instantly without adding any latency for the user. That's where our recommended enterprise setup using VLLM really shines. We'll be streaming the response, extracting the label immediately when it's generated, making the blocking decision instantly without waiting for the explanation, and also we'll be streaming the explanation asynchronously for logging and auditing purposes. We'll be saving the model by merging it with the adapter and the base model, and we'll be serving the merged model using the VLLM's OpenAI compatible API server. We'll be using 2 metrics. Time to label, that is how fast we can take the decision. Also we can call it as a decision latency, and the total response time. So this is the prompt injection template where we'll be injecting our user content, and it will be classified as either passed or failed with an explanation for the same. And we also have an inference helper function which will conduct the streaming process by passing a post request to the our VLLM API endpoint, and it will print the label and the time it takes to generate that label as soon as it is generated. I'll be running this cell and we'll see some of the examples. First we'll see the classic prompt injection attack. We can see that this input text assigns a new role or a new persona, calling it as Dan, and it overrides existing system rules, and it tries to bypass the safety controls, which shows clear prompt injection technique. And we'll be running this input text through our model, and we'll be inferencing, and we'll be recording the time it takes to generate the label as well as the explanation. It takes around 92 milliseconds to generate the label, which is failed, and also gives an explanation to why exactly it classified it as failed. Similarly, we have another example test case. This is a legitimate query, and it is used to implement a binary search algorithm for a Python, and this is prompted to an LLM. And if we pass this input text to our model, we get the label as passed, and the time to label is around 93 milliseconds. Also, it provides an explanation for the same. As already mentioned, for auditing purposes, it will be extremely helpful. And similarly, we have other adapters which you can find it on our Hugging Face page. Also, we have benchmarked our model against the proprietary model like GPT 4.1, which is comparably performing better. And also, it performs very well compared to other open source models like WildGuard and LlamaGuard 4. And also we have this custom safety categories, and we invite the open source community to build on this work, train domain specific adapters for specialized fields like medical compliance, financial regulations, or even education, and share your feedback with us. Together we can make AI system more safer for everyone. And here are few resources: Hugging Face model page and our paper. Please feel free to go through the paper, which has the entire process starting from the dataset curation, training, and as well as inferencing, and also benchmarking. And please do cite our paper in case you use it for research purposes or for inferencing. So thank you, and hope this is helpful for your deployments.